We are now coming to a new concept in the functions. We've got composition of functions. What is composition of functions? We are putting two functions. We have got two functions or more, okay? But here two functions are given to you. We've got two functions. We're composing one function into another, okay? So we are putting one function into the other one. That will be called composition of functions. So if I have got f of x, okay, and I have got g of x, if instead of that x, for example, okay, if I put that g of x into f, what will I get? I will get f of g of x. Look, instead of the x that I have got, I input g of x. That's called what? Composition function. Okay, g of x is composed into f. Or I can input the function f into the function g, of course, if it is defined in the domain there. So what will I get? G of f of x. Look, I put f of x instead of the x of g that we have got. So here f of x is composed into the function g. What are those two things called? These ones are called composition functions because we have composed two functions. Here, when we were talking, of course, about functions, we were saying that a machine is working. But when we are talking about composition of functions, two machines are working together. Okay? For example, if I have got a factory, okay? If I always give this example, if I put tomato into a function, okay, what will I get? I will get tomato puree, okay? If I put this one into another machine, for example, machine G, okay, I have got tomato, I put it in a machine, I got tomato puree, and then I put the tomato puree into another machine G. What will it make? It will can, okay, the tomato puree, tomato puree, okay. So what is here? Here two functions are working, two machines are working. The function f, the machine f, is making the tomato into tomato puree, and the machine G is putting the tomato puree into a can. So two functions are working together, two machines are working together to give one output. Okay, that's only one output that we have got here. If you have got an example here, it says compose those two functions. We have got example 1.16. F of x is given to us as x squared plus 3x plus 1, and g of x is equal to x plus 1. It's required from you to find f of g of x, okay, is equal to what? I will also add this part, okay. I will require from you to find g of f of x, okay. This one is the only requirement that's given to you, that's required from you, but I will also ask you to find g of f of x to see the difference between f of g of x and g of f of x, because in general those two functions are not equal to each other. Okay, let me write it for you here. That's an important note. In general, f of g of x is not equal to g of f of x. That's what? In general. There are maybe some points that makes those two functions equal to each other, but in general we cannot say that those two are equal to each other. Of course, later on we will study how those two functions will equal to each other. Okay, let's find the first requirement. It says find f of g of x. So what are we gonna do here? We are composing g into f. Okay, we are putting that g into each x that is given to me there. So instead of x squared, what will I write? I will write g of x squared plus 3 multiplied to g of x plus 1. Okay, why? Because instead of x, what do I have? I have got g of x. So what is g of x equal to? That's x plus 1 squared plus 3 multiplied to x plus 1, because g of x is equal to this, okay, plus 1. You've studied in college algebra how to open those brackets. That one is first one squared plus 2 multiplied to first one times second one plus second one squared. Okay, plus I'm multiplying this one to inside. That will be 3x plus 3, and I have got that one over there. We are adding the like terms, x's with x, numbers with numbers, and x squared is alone. So that will be x squared plus 2x plus 3x is equal to 5x, 1, 1, 3 is equal to 5. So f of g of x is equal to what? X squared plus 5x plus 5. Let's find g of f of x. G of f of x to see whether those two are equal to each other or not. What does that mean? That means instead of every x in g, I have to put f. What is g of f of x? That means f of x plus 1. Look, instead of that x, what did I input? I input that f of x that's given to me in here. So that will be f of x plus 1. What is f of x equal to? F of x is equal to x squared plus 3x plus 1. Okay? And of course, I have got that plus 1 over here. So that one is equal to what? Look, that plus 1 is here, and that one is the f of x that I have got. That one is equal to x squared plus 3x plus 1 is equal to 2. If you look at those two functions, the result of them, okay? That result and that result. That's f of g of x, that's g of f of x. Are they equal to each other? Obviously, they are not equal to each other. That's x squared plus 5x plus 5, and that one is 3x plus 2. So these two are not equal to each other, okay? F of g of x is not equal to g of f of x in general. We may find later on when we are studying the equation of functions, how to equate them, we may study, there may be numbers, points that makes those two functions equal to each other, but in general they are not equal to each other. Okay, we are having another word problem here. Example 118. Okay, here the word problem that is given to us, it's about an environmental study about of a certain community. For example, we have got a community here, okay, an environmental study of a certain community. That's any community. For example, Kurds, if you take Kurds as a community, suggests that, what does that environmental study say? Suggests that the average daily level of carbon monoxide in the air, okay, so we have got a study of a community talking about what? The average carbon monoxide level in the air. Okay, how is it given to us? It's given to us as C of P. Of course, when you are solving word problems, first you are reading the word problem all, okay? Then the second time, when you are reading it, you're coming to read it and stop by to analyze it part by part. So we have got an environmental study of a certain community, and we have got that study is talking about the level of carbon monoxide in air. How is the level of carbon monoxide in air? It is given as carbon monoxide level C of P is equal to 0.5 or 0.5 P plus 1 parts per million. Parts per million is the unit, okay, when the population is P thousands. So what is that P here? It is P thousand, okay? So if the population is 1,000, okay, the population of the community is 1,000 people, how can we find it? Let me write it here for you. C of 1, I will write C of 1. Why? Because it says P is in thousands. So if I write 1 in here, that means 1,000 people. How can I find the carbon monoxide level? It will be 0.5 multiplied to 1 plus 1. So that is equal to 1.5 parts per million in the air, okay? If I want to find the carbon monoxide level of 2,000 people, so how can I calculate this one? 0.5 multiplied to 2 plus 1. Calculate this one. You will get what? You will get the carbon monoxide level of 2,000 people in the air. Okay, so what is that P that is given to me? It is P thousands of people, the population. Okay, let's come to the other part. It is estimated that T years, so what is that T given to me in here? It's the time. How is the time given to me? In years. Look, it's not in months, not in days, it's given in years. Okay, so if I say T is equal to 1, so I have got 1 year in here. From now, the population of the community will be P of T. Let me write this one also. P of T is equal to 10 plus 0.1 T squared. Okay, so after T years, the population will change to what? Will change to that equation. What does that mean? For example, if I have got the population, after 2 years, if I want to calculate the population after 2 years, I will put T is equal to 2. Okay, that is in years. How can I calculate it? I will say population after 2 years is equal to 10 plus 0.1 multiplied to 2 squared. So that is 10 plus 0.1 multiplied to 4. 0.1 multiplied to 4 is equal to what? Is equal to 0.4. So that one is equal to what? 10.4. So the population after 2 years will be what? Will be 10.4 thousand people. Okay, if it is required from you to find after 3 years, so instead of that T, the time in years, you will put 3 and so on. So the P in here, that's the carbon monoxide. That C is representing carbon monoxide. Okay, the P is population in thousands, and population in thousand is given depending on time. Of course, the population changes depending on time. This year is different from next year. Okay, and carbon monoxide level is depending on the population. Okay, if the population is 1,000, it's different from 2,000 and so on. Okay, so on, we haven't done anything. We have only analyzed that part of the question. Okay, so let's come to the requirement. Let's see what is required from us. The first requirement, it says express the level of carbon monoxide in the air as a function of time. Okay, so it is required from us to find the carbon monoxide level depending on time. What is given to us in general, carbon monoxide level is depending on P, population, but the requirement, it says find the carbon monoxide level depending on time as a function of time. How can I find this one? Here I know that carbon monoxide level is depending on population, and population is depending on time. So composing this one into here, I will get carbon monoxide level as a function of time. So the first requirement, I have to find C of, what is P? P is population. So I will write C of P of T. Okay, look, that P, I input it into there, so I will get C of P of T. That's equal to what? 0.5 multiplied to P of T plus 1. What is P of T equal to? 0.5 or 0.5 multiplied, that one is 10. P of T is equal to 10 plus 0.1 T squared all plus 1. Okay, 0.5 is here. P of T is that bit. I put it here and plus 1 into there. 0.5 multiplied to 10 is equal to 5 plus 0.5 multiplied to 0.1 is equal to 0.05 T squared plus 1. Okay, because this one we are not multiplying it, it's outside of the bracket. That's equal to what? If I do it all together, that will be 5 plus 1 is equal to 6 plus 0.05 T squared. If you look at this one, we found the carbon monoxide level depending on time. Here is depending on population, P, we were inputting P into here, but here when we put the population inside the carbon monoxide level, we get a function for carbon monoxide, and that is depending on time. So after, for example, 3 years, carbon monoxide level will equal to what? 6 plus 0.05 multiplied to 3 squared. Let's go to the second requirement. So here we used composition function. We composed population into the carbon monoxide level. Let's move to the second requirement. It says, when will the carbon monoxide level reach 6.8 parts per million? What is required? When. When is what? When is time. T is required from us if carbon monoxide level is equal to 6.8. So carbon monoxide is equal to 6.8. It's required from us to find T. What's the relation between carbon monoxide and T? We found the relation. Carbon monoxide is equal to that T. So simply we write, instead of carbon monoxide, 6.8 because it's given to us, okay? This part is given to us. It's equal to 6.8 in the second requirement. So I will write 6.8 is equal to what? Is equal to 6 plus 0.05 T squared. We are searching for that unknown, okay? So I'm taking this one to the other side. 6.8 minus 6 is equal to 0.05 T squared. 6.8 minus this one is equal to 0.8 is equal to 0.05 T squared. Simply dividing both sides by 0.05. Why? To get rid of that part and leave T alone. So of course, using a calculator, you can use a calculator. That will equal to 16. 0.8 divided by 0.05 is equal to 16, and that part will go with this one. That will be T squared. So T is equal to what? If I am taking square root for both of the sides, that's equal to plus or minus 4. Of course, we are discarding the negative 4. Why? Because we are searching for time. Time cannot be negative 4. So we are saying T is equal to 4. What does that mean, T is equal to 4? That means after 4 years, the carbon monoxide level in the air will reach to 6.8. So that's all about that word problem. As I told you, how do we solve it? First, you are reading all the word problem, okay, without stopping, understanding it, okay? Then second, you are coming to read the word problem that you have got step by step or part by part, analyze it, what is given to you and what's required from you. You have to analyze it. Then, of course, if you could analyze the word problem, it would be easy for you to find the other parts that are required from you. That's all about section 1 of chapter 1, functions, domains, composition functions, and being familiar with word problems. I hope you would understand when you're watching the video. Have a nice time and bye.